All right, so I hope everybody had a good first day, the first Monday of the school year. Typically, we'll go ahead and start with basically a review, some of the bigger items that are going to be happening. You got your homework assignment. Picked it up on the way in today. It's going to be due tomorrow. We'll come in, grade it, answer questions, and then we'll move on to our next section. We're going to talk a little more about functions tomorrow. Hopefully get to piecewise functions by the end of the week. Next week, I want to solve rational inequalities using sign charts. That's my goal, to get that material in before next Thursday, which is your what? Test. Okay, so the test is next Thursday on the 30th. What's happening this Thursday? You got a quiz. Now, it's over this current material right here, but I didn't worry about functions just yet. I'm going to go ahead and put that on hold until we get to the more in-depth lesson. But I really focused on sets more than anything else. Union, intersection, the complements, and we're going to review all those, in just a second. So that's coming up on Thursday. Don't think it's going to be too bad. Did everybody get my, welcome text last night on Remind? Did anybody sign up for it and not get it? Or does anybody still need to sign up? Okay, if you still need to sign up, right over here on the backboard, Pre-Cal IS, there's the code at 66K7KK. That's the one you'll want. Okay, and I'll be sending out reminds. I'll probably send out the next one tomorrow, letting you know, hey, don't forget about the quiz on Thursday, things like that, test coming up. But I think unless anybody has any questions, we're good to go. All right, let's do it. Now, every class was a little different. How far did we get? I don't remember. Did we get to 2A or 2B or not 2B?
Yeah, we were on 2D.
Yeah, you see what I did there. Okay. Zachary. So we were on 2C or we finished 2C? Okay, so we were done with 2A and 2B. All right. So we've been talking about unions and intersections. Let's just do a quick review of those. What are the symbols for a union? Okay, so a capital U or a capital V, and what word was associated with that? Or. Okay, elements in one set or the other. Now the intersection. Okay, what were those symbols? Okay, so the arch, the upside down U, the upside down V, and keyword and. So the difference, the union is a combination. I described it as a marriage of the two sets. Okay, while the intersection is going to be those elements that they share, what they have in common. If you were to look at it visually in a Venn diagram, it'd be the overlap. Okay, and then we started talking about the complement, which is what we're on right now. So we have the universe going from 0 to 9. We have sets A, B, C, D, and E. So it says find a complement. That's that little tick mark. Can anybody help me remember, what does it mean, complement? Not the actual complement, like what does it mean for sets? Someone describe it in your own words. Hey. Okay, so he says all the numbers in the universe, but not included in that set. That's perfect. That is absolutely perfect. So the universe goes 0 to 9, but set A only has 1, 4, 5, 7, 8, 9. So basically, we want to remove those. What elements are still left in the universe? Okay, 0, 2, 3, and 6. That would be the complement of A. Remember also, yesterday we brought up the idea, if I take the union of a set and its complement, that's the what? That's the universe. Okay. What's the intersection of a set and its complement? That's the empty set. Okay. We also called it the null set, or I could use that little symbol 0 with a slash through it. Perfect, perfect, perfect. Okay. So this one, find the complement of set D. Well, D only contains 2 and 3. So what would that be? 0, 1, 4, 5, 6, 7, and this goes to 9. There we go. All right, so pretty easy, right? Anybody having any issues? Okay. Cool, 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 cool. All right. Let's see what else we got here. If two sets have no elements in common, their intersection is called the empty set or the null set, and was written using that symbol. Okay, so let's go ahead and practice this, and I'm going to go ahead and give you an extra one, and I'm going to see if I can get somebody up here to go ahead and draw a diagram for me. So let's see. The universe consists of 1 through 8, okay, just those whole numbers, or natural numbers, depending on how you want to describe them. So R is made of elements 2, 4, 6, S has elements 4, 5, 6, 7, and T only has the one element 1. So what am I asked here for in 3A? Okay, the union. So the union, remember, is the combination. I want to take every element in R and combine it with S. Now, what if I have repeats? Do I have to write them twice? Okay, so Stephanie said no, we don't have to do that. Okay, so Stephanie, what would you say the union of sets R and S is? 2, 4, 5, what? 6, 7. There we go. Okay, perfect. Now, union, like I said, is a marriage. It's a combination of everything you see in the two sets. But the next one, that's the intersection of sets R and S. What am I looking for here?
Numbers that are both the same.
Yeah, only what they share. What's both in R and S? 4 and 6. Okay, perfect. Perfect. What would be the intersection of T and S? Empty set. They have no elements in common. Yeah. So empty set, null set. I'm going to go ahead and put the symbol. All right, let's go ahead and try this. I'll give you, let's say, 30 seconds. Try this one. I want the intersection of set R and S's complement. Okay, let's try this one. Yes, sir. Oh, S1, that means the complement. So I'm looking for S complement is the elements that are still in the universe, but not in set S itself. Okay, so let's see. By show of hands, how many people think they know what the answer is? Okay, so a lot of hands going up. Good, sir. What do you think?
Okay, 2.
It is 2. Okay. Because what would S complement be?
1, 2, 3.
Okay, so S complement is just 1, 2, 3, and 8. So, if it helps you to write that out before you go ahead and actually tackle the problem, that's great. If you don't need to, that's fine. So now I want the intersection between R and that S complement set that we just created. And the only ones they have is 2. How many people got that right? Okay, that's interesting. That's more hands going up than when I asked, okay, how many people have an answer? Okay, how many people had the answer, but they just weren't confident? Okay, you got to be confident. Okay, have confidence in yourself. Even if your answer is wrong, so what? That's how we learn. Okay, I'm going to stand up here. I'm going to get things wrong from time to time. You're thinking, Mr. West, come on, you're a rock star. I know, but I'm also human. I'm going to make mistakes. It's going to happen. Okay, I think I've already made a mistake in here, right? No? Okay, well, I know I'm about to show you a mistake that I previously made. So your whole world is probably about to shatter. Everything you know about reality is going to be questioned because I'm wrong, but that's okay. Okay, we'll get through it somehow. All right. Very, very quiet when I said all that. Yes. Awkward silence. Okay, conjunctions and disjunctions. I mentioned these yesterday, and we'll be looking at those probably in a little more detail coming up tomorrow. I think tomorrow is when I might decide to go ahead and use our first focus activities. But what is this capital upside down V? What's it represent? Okay, it's and. What are we talking, intersection or union? Intersection. So a conjunction is another way of describing an intersection. We like to use these with what we refer to as compound inequalities. I'm going to show you some problems on those soon. So if a conjunction represents an intersection, disjunction would be a union. There we go. And then I've got this down here. We actually haven't brought this up before. We've seen it. If two sets do not intersect, we say that the intersection is the empty set or the null set, but we can actually describe those sets as disjoint. Okay, so if two sets do not intersect, we can say they are disjoint. Okay, so let's go ahead and do one more thing. And then I think after this, all we have are just the classifications. So that shouldn't take but 5 minutes. But before we go ahead and leave this problem, the universe R, S, and T, I'd like to invite somebody up here to go ahead and draw a Venn diagram representing the situation. And I'll go ahead and get you started. I'll draw the rectangle for the universe. And typically when you draw the universe, in one of the corners, you go ahead and put U to represent the universe. Some teachers might be more sticklers about this, probably in statistics or even maybe theory of knowledge where you're talking about this stuff. But some may go ahead and have you put the number of elements in the universe. I'm not going to be looking for that. I'm really going to be more concerned with the sets themselves. So who thinks they could come up and visually represent sets R, S, and T? Okay, Skylar, you want to try? All right, come on up, sir. There you go. Okay. Yeah, so here's my first question. What's the relationship between R, S, and T? Do they all three intersect? Okay, none intersect, only two intersect. What do you think? Okay, so how are we going to visualize that? Okay. So you've got R and S. And then we'd have to have some other set. Very good. Okay. Now we do have to go ahead and write the elements. Yes. So 1 belongs to T. Okay. There you go. So you had it right the first time. Okay. Now let's see what he drew so far. He drew R and S overlapping, so he put 4 and 6 in the intersection. 2 still belongs to R, but not to S, so we have it in the strictly R portion. 5 and 7 belong to S. So far, everything is perfect, but are we forgetting anything?
Yes.
What are we forgetting? There you go. Now, the rectangle still contains the universe, so do we have any elements that are in the universe, but in none of the sets? 3, and there's one more. 8. There we go. And, as long as those are in there someplace, I mean, there's no right or wrong place to put them as long as they're, are labeled. Very good. Very good. Does anybody have any questions on that? No? Okay. Good, 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 good. Well, let's go ahead and talk about how to classify numerical values. And then that will do it for this particular lesson. And then the rest of the time, I'm going to give to you folks to go ahead and work on your assignment, which is due tomorrow. Okay. So let's see. What you're accustomed to, every value can always be categorized as real, correct? And then the reals were going to be broken into the rationals and the irrationals. Okay, if it was rational, you had a subgroup, the integers, another one, the whole numbers, and then the natural numbers. Now, for these, if you look down at the bottom of your sheet, you have these set notation mathematical definitions that'll help you with these. So, for example, look at Q. Q is the letter we use to go ahead and represent the rational values. So it says all values A, B, okay, A divided by B, so it can be written as a fraction. What's the colon? Such that, so it says A, what? The curvy E, what did that mean? Contains, is a member of, belongs to. Okay, so A belongs to, what group represents it by Z? The integers. So A belongs to the integers, and B is an integer, and what? B can't equal 0. And that makes sense because what's the one thing you can't divide by? 0. So we have to have that restriction in there. So basically, if it can be written as a fraction, by definition, we're going to classify it as a rational number. But we're going to go ahead and expand this. So the reals are actually a subgroup or a subset of an even larger group that we're going to call the complex. So the complex is actually made up of both real and imaginary. So up to this point, you've probably been using the letter I, a capital I, to go ahead and represent irrationals. But now that we have the imaginary, we're going to use the capital I for that. So we're going to go ahead and use R minus Q for the irrationals. Or you could say R slash Q. I kind of prefer to use r minus q, but whatever. And it makes sense because if you take the reals and you subtract off the rationals, well, what are you left with? Irrationals.
Why couldn't you make your own letter for the irrationals? Why did it have to? Why did it have to be like defined by the other sets and not their own?
That's an excellent question. It's just what the consensus of the mathematical community was a very long time ago. Excellent question. I mean, I don't know what reasoning they used. I mean, what variable represents slope? M. To me, it just seems like a completely random number. Maybe there was some kind of reasoning behind it. I don't know. But, it is what it is. So that's one of those questions I don't have an answer to. So there you go. Okay, so complex, let's go ahead and take a look at it. It's all values that can be written in this form, a plus bi, such that both a and b are what? They're both real, and I, by definition, is going to be the square root of -1. So you probably remember this from Algebra 2. Complex is going to be a combination of some real value and an imaginary unit. Okay. Now, if you only have the imaginary unit, then we're going to classify it as imaginary. Okay. But if it does contain the real portion, if it adds or subtracts some real value, then we're going to be able to say it's real, and we can go ahead and continue to classify it. So give me a number. Any number. 2. Okay. Let's say 2. Now, some people like to start at the bottom and work up. I kind of prefer to work from the top down. I think it just makes it easier, but whatever works best for you. Can I say that 2 is complex? Okay, yes. 2 is complex because we see by the hierarchy, do the reals belong to the complex? Yes, and just think about it. Could I rewrite 2 as 2 plus 0i? And think about the definition. Here's A, here's B, and it says both A and B are real values. Are 2 and 0 real? Yes. Okay. So it's just like if I want to write anything as a fraction. We can always put it over what value? 1. So anything can be turned into a fraction by putting it over 1. Okay. Which actually is going to help us in just a second. So 2 is complex. Is it real or imaginary? This one's real because it does not have the imaginary unit. It's 0i. So I'm going to go ahead and say real. Is it rational or irrational? Okay, it's definitely rational. So I'm going to go ahead and put Q. And we're going to come back to irrational in just a second. So is it an integer? Now, does everybody know the difference between the integers, whole numbers, and naturals? Or does anybody need me to clarify? Okay, so Jane, correct? Okay, so let's start with the naturals. These were the first numbers that you were ever taught in school. What am I referring to? Yeah, 1, 2, 3, just your counting numbers, right? So 1, 2, 3, dot, dot, dot. Okay, and then as you got older, the lessons started to get more complex. They started to introduce you to new ideas. What's the one difference, the only difference between a whole and the natural set? 0. The whole numbers include 0, the idea of nothing. So 0, 1, 2, 3. Okay. Now, moving up into the integers. The integers contain 0. They contain the natural numbers, but also what else?
Negative.
The negatives, they're opposites. So for the integers, I'll go ahead and do this over here. Z is equal to, you could have like -2, -1, 0, 1, 2, dot, dot, dot. Okay. And then, of course, when you get up into the rationals, those we've already talked about. Okay. So it is true, 2 is rational because you can put it over 1. By definition, it can be written as a fraction. Is it an integer? Yes, we see it right there. Is it a whole number? Yes. Is it a natural? Yes. And just FYI, especially if you're one of the IB students in here, IB doesn't refer to them as natural numbers. Does anybody know what they call them? What's that? I heard somebody say something. What's that, Scholar? Counting? No, it does start with a C, though. They call them cardinal values. I don't know. IB likes to do things differently. Okay. But there you go. Now, before I go ahead and give you another example, Let's talk about the irrationals for just a second. There are two conditions that have to be satisfied if a number is classified as irrational. So let's start with the most famous irrational number we have. What is that? You've used it a lot. Pi. Pi is probably the poster child for irrational numbers because it's the most well known. But there's two things about pi that classify him as irrational. Anybody tell me one? Okay, what's that? That's exactly right. Skylar says it goes on forever. It has a non-terminating decimal. It has an infinite number of digits. That's one, and there's something else. It never repeats. Now, if it does go on forever and there's a noticeable pattern, it's what? It's going to be rational. If it's never ending, if it goes on forever and there is no pattern that you can tell, okay, then it's going to be irrational. Okay, and pi definitely does that. Okay, so as far as pi is concerned, I can label it as complex. It's real, but then it would have to be irrational. Remember, it's real easy to forget and go back into, capital I thinking irrational, but now we're to the point, capital I is imaginary. We're going to say R minus Q or R/Q is going to be irrational. Okay, let me go ahead and give you another one. I'll go ahead. I should be able to finish up real fast and take the roll. How about negative 2/3? Is it complex? Yes. Is it real or imaginary? It's real. There's no imaginary unit. Okay. Is it rational or irrational? Definitely rational because Q, rational, means it can be written as a fraction, and it is a fraction. Okay. Is it an integer? No. And if you stop at integers, that means it's not going to be what? It's not going to be anything below it, a whole or a natural. In fact, when you're talking about natural, wholes, and integers, those do not contain fractions or decimals. So he only belongs to 3 groups. Okay. Let me go ahead and give you another one. How about the square root of negative 36? Now, some of these you may have to simplify before you ever start to classify. Okay. Ethan, can you help me out? What would the square root of negative 36 be? 6i, perfect. Okay. Only one class so far has asked me to kind of elaborate on that. Does anybody want me to go through the process? We remember, okay, I's have it. You ever heard one of those formal meetings? Say aye or nay, the I's have it. We're talking about I. I feel it's not as funny if I have to explain it. Okay, yeah. Anyways, 6i, is it complex? Yes. Okay. Is it real or imaginary? It is imaginary because we do have the imaginary unit. Okay, so I can't go any further. Okay. All right. Are we starting to get the idea? Okay. Does anybody have any questions? Anything we've talked about today you want me to elaborate on? Or anything that's going to be happening? Yes, sir.
Is there any number that isn't complex?
No, because the way we base our number system, everything can be deemed complex because you can add or subtract 0i on the end of it. Okay, and it's one of those things you were probably told this in algebra 1. It's more like math etiquette than anything else. I mean, it still has the same value, but we always prefer to put the real value before the imaginary. Okay, so if I were to give you something like what we talked about earlier, like maybe 2 plus 3i, it's preferable to write it in that way instead of 3i plus 2. Even though we know it's the same binomial, it's just math etiquette. Okay, it's like when you're drinking tea with a fancy glass and you got to put your pinky out. You don't have to do it to drink it, but people do. It's really awkward standing here with just my pinky out. Okay, so I'll stop there. Okay. All right. Any other questions? How we doing? Okay. Well, I have 30, so that means you have 22 minutes to go ahead and take a look at your assignment. This is not a quiz. It's not a test. So I actually encourage people to work together. No, that doesn't mean just copy another person. No, this is the opportunity. So if you're having trouble, ask me a question. Ask other people questions. See if we can figure it out. Also, these opportunities, when we have them to work on an assignment in class, this is one of the rare opportunities. You can go ahead if you want to take out your phone. If you want to listen to music, I listen to music while I'm working. I like it in the background. The only thing I ask is that you do what? That you do work. Okay, so don't work on another class. Please work on this. If you happen to finish, great. If not, you'll hopefully get the majority of it done before you take off. Okay, questions? Okay, let's